satellites. Yes, it does. 3-axis stabilization for the Corona photo reconnaissance satellite, which is pretty fascinating stuff. So we're going to talk with the presenter right now. Hi, can we ask you a few questions? Thank you. So could you explain why you're at STEM today?
Sure. I'm here to explain the satellite program called Corona. It started in 1957 and went operational 1960 in terms of photographing the Soviet Union during the Cold War. This went on until 1972. All of that was declassified, all of that activity, the program, and even the film that came back that was recovered from space was declassified by President Clinton. Vice President Gore wanted that film to be used for environmental comparison purposes. As an example, we have a picture of a lake showing the shrinkage of the lake with a current NASA color photograph. This is an idea of what's used with 410 miles, and these are pictures that are 2 feet long, so there's lots of it. The way it worked was that there was a vehicle called the Agena, and in fact, it's the only satellite vehicle that was ever produced in a large production lot. There were 300 of them built for the national intelligence purposes, either photography, reconnaissance, or radio reconnaissance. And of course 200 for NASA. A lot of their space work used the Air Force vehicle. The vehicle is about 21 feet long and had 2 cameras built by iTech here in the Boston area. The film was taken sporadically depending on the program of the areas they wanted to cover. They turn it on and off, and they even could arrange if there was a cloud cover over a large area, they wouldn't bother wasting the film. But you can see it's sort of a staggered group of film. When it's all finished, the film had been caught on a roller up in the capsule, an airtight roller. And at the end of the mission, which might be several days, or in the case of in 1972, they had actually extended it to 2 capsules and even 19 days to bring back the second one. Anyway, you would disconnect, and the capsule would float down through space and meet an aircraft coming out of Hawaii that had what they call a trapeze hanging from the back of it. This trapeze would fly over the parachute and catch in the rigging, and then it would be a big load, and it would reel out like a fish reel when you get a big bass on it or something like that. They would reel it back in, collect it, and bring it back to the ground. Just to give you an idea of the kind of resolution of the pictures we took. This is a picture, an actual print, enlarged from Moscow in 1970, and you can see the river here and a little boat with a wake. But more importantly, if you look at this line here, this is a monument called Lenin's Tomb. There's a line of people going in to view the tomb. From 100 miles up, you can clearly see the line of people. This is probably the same sort of resolution in Google Earth today, but remember, we were achieving it for military purposes back in 1970. All this photography was used for developing the worldwide grid, which is the WGS-84. That's the sphere of the Earth that's used for the current GPS system. All the satellite systems have to have maps in order for these little receivers to work. This was used as the sole source of all the data for WGS-84 till 1996. And later, after I had left iTech and gone to another company, the company built a camera for NASA. This cost $10 million for one camera. And it took a picture on a 9x18 format that was 5-meter stereo resolution. And you could definitely distinguish and map houses on it very accurately, much more accurately than with Corona. So this was the future for mapping, was these kind of cameras from NASA vehicles. My company had also, in my project group, had done a camera on the SR-71 as an early CIA model for it was called the A-12 then, and the Air Force built a larger SR-71 version. That's a Mach 3 aircraft that had iTech cameras in it. So that's sort of what I was trying to show here. I happened to be lucky enough to be at MIT at the very time, and they got an Air Force study contract to implementing a satellite program for reconnaissance. And I was able to follow it up for a career for some 15 years. So it was a real opportunity, and that time it's kind of odd because the entire program, including Thor boosters, which are the same as used for NASA, today in Delta missions and whatnot, GPS launches. That plus the Agena vehicle, plus the cameras, plus the recover, only cost a total of $840 million. Today, that number, you couldn't even write a proposal to do something with respect to space. So we did it with a pretty hard driving crew that actually, I hate to admit it now, but we had no idea what we're doing. We just did it. So.
Could you talk a little bit about like the academics that you'd want to gear yourself towards in high school kind of thing in order to get into photography and like making all that kind of awesome stuff?
Yeah, in high school I took trig and I took solid geometry. I like solid geometry, and they didn't even offer calculus. And I went to an engineering school, and they didn't even teach differential equations at that time. So I would say take all the math you can get. Because when I went to MIT, without the calculus background at all, even in my engineering course at State, I had a hard time the first term at MIT. I was there in a 21-month program that the Air Force had sent me on. And I'd say take the math, and in high school I also took physics. I had a choice for some reason between physics and chemistry. I wish I had taken both. But certainly in my case, I'm glad I took physics because I'm more leaning that way. In fact, the thing that really got me into engineering was that during World War II in North Carolina, they allowed young people to get licenses at 14, if you can believe it. And at 14, I was able to buy a car when I was 13. And my parents told me if I could get it running, because I bought it, the entire engine was in a bushel basket, all the parts taken apart. And they said if I could get it running by my birthday, I could have it. That was the thing, and I worked on Model A Fords and putting V8s in them and hot rodding. That gave me a mechanical inclination, but more important than that is I learned how to do things on a schedule. When my parents gave me the challenge, I could have something if I did it on a schedule, you'd be surprised what you can accomplish. So experiences like that, hands-on experiences, I'd say are worthwhile. Take all the math you can, physics, chemistry, science.
Thank you very much.